Okay, the next topic that we're going to be dealing with is called the log rule for integration. Now this really makes life simple, but it's again a matter of mathematical manipulation. Something that you guys have gotten really, really better at as the years progressed. So we're going to continue to work with that. The basic rules for this is that the derivative of 1 over x dx is equal to the natural log of the absolute value of x plus c. Okay? And that means then in terms of u is exactly the same thing. 1 over u du equals the natural log of u plus c. Or, since the differential of u is also known as u prime, you can rewrite this as u prime over u equals the natural log of u plus c. So it's, again, using the chain rule that we learned way back when. And since most of you are pretty familiar with this should not be too much of an issue. I did do some samples that the book used, and I gave it a lot more context than they did, so that you can understand the types of problems that you are going to be dealing with. The first two that I have here, this one is the integration of 2 over x dx. We take the 2 out, and then gives us 1 over x dx, which is the same as dx over x, or x prime over x. So that would be 2 times the natural log of x plus c. You can leave it there, or you can move that as an exponent of x squared, and because that's positive, we don't have to worry about the absolute value sign in the final construct. You probably would have to if you left it with the 2 not being part of this x as a square. The second one is this derivative right here, and you do the usual thing that we always do. We make 4x minus 1 is u, and that means the derivative of u is 4 times dx, which I have here, and then you are going to want to introduce the du in terms of dx, so I divided both sides by 4, and dx then became du over 4. Plug that in right here, so 1 over 4x minus 1 is 1 over u, and dx is du over 4. So we take the 1/4 on the outside, du is u prime over u, and so that's going to be 1/4 times the natural log of u plus c. And there you just replace the, actually I should have the symbol there, like that. I forgot to put that in there, and that gives you 1/4 times the natural log of 4x minus 1 plus c. In finding an area, it's the same idea. If we were trying to find an area of a region that is defined by this, and is going from x equals 0 to x equals 3, or y equals 0 to y equals 3, and probably the x-axis on top of that. Anyway, so finding this thing, we make u this value right here, then we derive u, and that gives us 2x dx, and since we have just plain x dx, we're going to divide that by 2, so x dx is du over 2. So the idea is to try to make x dx the value that's to be substituted, so you have to divide that 2 out. And so now you go ahead in terms of u, plug that in. Well, x squared plus 1 is in the denominator, so that's 1 over u instead of just plain u. And we said x, and or rather x dx then is half of du, so put du over 2. I take that 1/2 and put it out because it's a constant, and this gives us du over u, or u primed over u, and that's going to give you 1/2 the natural log of u. Well, u is x squared plus 1. We put that in the absolute value symbols right there, and so it's a substitution there. And so this is going from 3 to 0, so we're going to take 1/2 of 3 squared plus 1, which is 10. So 1/2 the natural log of 10, minus 1/2 the natural log of 0 plus 1, which is 1. Well, the natural log of 1, or any log of 1, is 0, so that really just kind of drops out. But, you know, if you're not sure, you just go ahead and calculate in there with that, and you will get an answer of somewhere in the neighborhood of 1.15. So you can find an area doing that as well. Recognizing quotient forms of the log rule. Again, more mathematical manipulations using u. In this case here, x cubed plus x is going to be our u. We take the derivative of that, and we get 3x squared plus 1, which just, and then dx, of course, and that just happens to be this numerator here. A weird coincidence, who would have thought. So this is going to give you du over u, or u prime over u, which is the natural log of u plus c. So you just take this x cubed plus x, plug it in there, you're done with it. All right? Another one. This is, it looks a little complicated, but it actually is not if you understand, and this is where the tables become real important for the derivation and integration of trig functions. We're going to make u the tangent of x because the derivative of the tangent of x is secant squared x dx. And that makes it really convenient as being u prime over u that you take the derivative of. So it's the natural log of u, and we define u as the tangent of x. Very simple. Next one, we're going to make u this denominator. And notice this is happening a lot. Because we know that we can get the natural log of u put in when we have this figured out in terms of du and dx, then this becomes a much simpler problem. So that's what we're going to do. We're going to make u x squared plus 2x. And then we take the derivative of u, which is 2x plus 2, times dx. Well, we don't have that up there, but what we do have is x plus 1 dx. So I can factor a 2 out of here, and then divide by that 2, and that tells me that du over 2 is equal to x plus 1 dx. So I come over to this original formulation here, and this is my u in the denominator, so that's 1 over u, times x plus 1 times dx, which is, we just said, du over 2, then plus c, which I forgot to put in, which is why it was so clumsy. But that gives you the derivative of u prime over u plus c, which is going to give you the 1/2 the natural log of the absolute value of u plus c. Now we're ready to plug in the x squared plus 2x, and voila, there's our answer. Next one, same kind of deal. We're going to make 3x plus 2, my u. But all I have on top is dx. But if I take the derivative of 3x plus 2, I get 3 dx. And I have 1 dx on top, so I need to define dx, or 1 dx in this case, as du over 3 when I divide both sides by 3. Now I'm ready to plug stuff in. So this becomes 1 over u because of that, and dx becomes du over 3 because that's what I found over there. That gives me a fraction of 1/3 that can be pulled out, which I did right here. Du is u prime over u, and now we are ready to put in the natural log of the absolute value of u plus c with the 1/3 front, and now we just plug in the 3x plus 2 for my u, and there's our answer. So that's the process you're going to be using. Your practice problems, page 338, 4, 8, 10, 12, 16, and 20. Have fun.